Today's topic is dilations. Today we're going to dilate about the origin, and you can use the date of May 27th. Your notes are 5 pages long. These are the first 3 pages and the last 2 pages. And you'll also need either a straight edge or a ruler so that we can make our examples look really good. Let's start with the definition of dilation. This is another transformation. This time what we're going to do is either stretch the figure or shrink the figure, and we're going to use a center of dilation. That's a fixed point that we will dilate around. Today we're going to dilate about the origin if the center of dilation wasn't known, and tomorrow we are going to move it away from the origin. What we can do is make lines connecting a pre-image point and the image point. And what you'll see is eventually those lines will all intersect at a common place, which is the center of dilation. Today we'll see that they always intersect at the origin, and then tomorrow we'll have to locate where that new center might be. When you dilate a figure, we use a constant of proportionality or a scale factor to do the enlarging or the reducing. We use K to abbreviate it, and usually the rule is presented to you, and then you follow that rule. We abbreviate a dilation with capital D, and then in subscript, you put the dilation rule. So for the first example, we're going to dilate our figure by a scale factor of 2. So our new image will be twice as big as our pre-image. You can also use values that are fractional in nature. So this dilation is going to reduce the figure to half of its original size. You can see in the picture, the penguins is where we're starting. The pre-image is actually larger than the image. That tells me that the scale factor is some kind of fractional value. So when K is less than 1, we know that the figure is going to be reduced. And this is something that you know ahead of time. So if it's not smaller than what you started with, we already know that there's a problem. In the second picture of the United States, the pre-image is smaller than the image. That tells me that the scale factor K was greater than 1 and that the figure is being enlarged. It's also possible for a scale factor K to be negative. So not only are you reducing it or enlarging it, but the negative sign will make the image flip over and face a different direction. So if we have our pre-image in blue, maybe our scale factor is 3. If it's positive 3, I'm making it 3 times as big. You can see it's the same shape, but it's clearly a different size, but they are facing the same direction. If I made the scale factor negative 3, it will turn into this red figure. Not only is it the same shape and it's 3 times as big, but now it is facing a different direction. It actually looks like it's been rotated a little bit. It's also possible for your scale factor to be equal to 1. That means the pre-image and the image will be identical. So this is more of a congruence than a similarity. So if you want to dilate and we're using a center of dilation at the origin, the general rule says, take your generic point P located somewhere in the coordinate plane. It will map itself to P prime. We're going to multiply the scale factor K times the X coordinate and the scale factor K times the Y coordinate, and that will tell us where the new location is. This works with scale factors that are positive and whole, and it works with fractional scale factors as well. Our first example says, what is the image of the point 5,3 under a dilation of 8? That tells me that the scale factor is 8. We're going to multiply 5 times 8 and 3 times 8. I'm showing it in this first example, what it's happening. You don't have to show this step. You really can just tell me where it's going. So my new location will be at 40, 24. If we dilate with the center of dilation at the origin. By telling you that, that just confirms that the multiplication rule we just established will work. The image of A is A prime. We're looking for the coordinates of B prime, which is the image of B under the same dilation. They did not give us the scale factor or rule. So to go from A, which was at -2, we went to A prime, which is -6. Think about what you would multiply by. And then from -3 to -9, we're also multiplying by the same value. So the rule is dilate by a scale factor of 3. Now that I know this rule, I'm going to go ahead and apply this to B. So 4 times 3 is 12, and 0 times 3 is still 0. And my location of B prime is at 12, 0. In example 3, they want to know which quadrant would the image of 5, -3 fall after a dilation using a factor of -3. Let's apply the rule. We're going to multiply 5 and -3 by the scale factor. So my new location will be at -15, 9. If you're not familiar with the quadrants, they're labeled 1, 2, 3, 4. If you can imagine, -15 would travel to the left and then up. So we know that our answer would lie in quadrant 2. In number 4, again, under a dilation with respect to the origin, so our multiplication rule works. The image of P is P prime. What is the constant of dilation? Basically, what is the rule? We went from -15 to -5. Most of you are going to say that we divided by 3, and I agree with you. But the dilation rule is always a multiplication rule. So instead of saying divide by 3, we're going to say we actually multiplied by 1/3. So keep that in mind when you see problems like this. Our first graphable example, we have quadrilateral ABCD. We're going to dilate it by a scale factor of 1/2 to produce its image. I'm going to start by graphing my original quadrilateral. You'll want to use a ruler to connect your points and then make sure all of your vertices are labeled for the perfect image. We're going to go ahead and apply our rule. We're multiplying 4 by 1/2 and then 0 by 1/2. So A prime is located at 2, 0. I'm going to do this with B, C, and D. And now that we know where the prime locations are, we're going to go ahead and graph our new quadrilateral and label all of our vertices. Because our center of dilation, we believe, is at the origin, we have our pre-image and our image maintaining their same shape and they are facing the same direction. Now, normally, we can connect C and C prime, and A prime, D and D prime, and B prime. But I think you can see visually they're all going to have those lines intersect at the origin. So our center is confirmed at 0, 0. In example number 2, we have triangle XYZ, and now we're dilating it by a scale factor of -2. Let's go ahead and plot triangle XYZ and label our vertices. I'm going to apply my multiplication rule. So multiplying by -2, I'll have X prime, Y prime, and Z prime. And remember what we said prior, we're going to change this and make it twice its size, but the negative is going to flip it over. So there is my new prime image. And to confirm that the center is in fact at the origin, you can connect any point and its image. I'm going to go ahead and connect Z and Z prime. You can see it's passing through the origin. I'm also going to connect Y and Y prime, and that further proves that the origin is my center of dilation. You don't necessarily have to draw the lines on your homework, but this will be helpful for tomorrow as we move forward with more dilations. In example 3, we have triangle map. We're going to dilate by a scale factor of 2/3. Being a fraction, I know that I'm going to shrink it down. This time, though, the use of the grid is optional. I'm not going to use the grid to plot the original. I'm going to go ahead and apply my rule. If you're not good with fractions, you can go ahead and use your calculator. You first want to multiply by 2, and then you want to divide that answer by 3. So m prime, a prime, and p prime. Now, without a visual, it's hard to determine if the center of dilation really is the origin. I'm going to take a second, and I'm going to plot m and m prime. And if I draw a line through them, you can see that my line does pass through the origin. We do need to confirm it with a second point. I'm going to plot A and A prime. There we go. And when I draw a line through them, you can see that it does also pass through the origin. So my center of dilation is confirmed at 0, 0. When you dilate a figure, what we're going to get is an image that is similar. So it'll be the same shape, but it will no longer be the same size. So under a dilation, we are not preserving distance between points. Your sides are going to either shrink or enlarge. This is homework number 127. It's a two-sided paper. Make sure for 16 through 18, you do complete mappings where you state the original points, and then you draw the dilation rule and put down your image points. When you get to number 18, both of these parts require you to build on to cow prime to get cow double prime. So make sure you don't start over, you just build off of what you already have. If you have any questions, please make sure you get in touch with me. Otherwise, have a great day.